Hello, and how are you, students? I welcome you to our lesson, Physics from 1, and it is a continuation of our previous lesson where we learned about the particulate nature of matter. We are in the process of trying to look at the demonstrations of showing us how matter exists in smaller or tiny particles. I want to remind you that right now we are living in a period where we have this disease, COVID-19, and therefore I want to tell you that to be safe, you need to wash your hands or even sanitize using the hand sanitizers. And when you are in a group of people, remember to wear a face mask so that you do not contract the virus. So, I'm calling upon you to join me in this class so that we go together looking at how matter exists in tiny particles. My name is Mr. Joha, and today's objectives are that we or you, the learner, should be able to explain that matter is made up of tiny particles. Matter is made up of tiny particles. We are on our fourth demonstration, where we want to look at how this matter also exists in tiny particles. And we are going to look at dissolving a solid in a solvent. Dissolving a solid in a solvent. The apparatus include a flask with a stopper, salt, and then we have some water. And we are going to put 100 grams of salt in the flask, 100 grams in the flask, and add some water carefully using a pipette or using the water bottle without shaking first until the flask is full. And we have the flask is here, so we are going to put some salt there, 100 grams of salt. That much. So then we add some water. We are going to add some colored water so that it becomes a bit visible. So we add some water, until the flask is full. And then we put the stopper there and shake so that the salt dissolves. Now this experiment takes a lot of time, because the moment the salt has dissolved, you have to keep it and settle for some time for the experiment to be fulfilled, to be complete. And so we have another setup that we have brought with us so that we look at what happened, the setup that we did previously, and the same experiment so that we look at what happened. So in our second set, this is the one where we have dissolved the salt and we need to keep it and settle for some time so that the experiment will be complete. This is the one we have as observed. Now, we are seeing that in this second setup, there is a space that is left. There is a space that is left after that solution has settled. After the solution has settled, after some time, 30 minutes, 1 hour, we realize that there is a space that is left at the top, as shown in our diagram there. Our diagram is showing set A is where we have dissolved the salt. Set B is where the system has settled, and now we have a space, an empty space left. Now what does this actually tell us? What does that tell us? In set B, where it has settled, it is showing us that the volume of the solution of salt, the volume of this salt solution is less than the volume that we had dissolved initially, because there is a space at the top that is left. And from this we can conclude that the particles of salt are able to occupy the spaces between the water particles. The water particles that we have added have some spaces. Actually, water particles have some spaces in between them. So the salt particles occupy those spaces between the water particles. And we were expecting the solution to rise up, but instead the solution went down. It's because when the salt particles occupy the spaces between the water particles, the level went down. Since the particles of water and the particles of salt differ in size, the particles of salt and the particles of water differ in size. But remember, the particles of water have some spaces. So those particles of salt occupy the spaces, fit themselves into the spaces which are in between the water molecules. And therefore, in the process of fitting themselves there, the volume reduces. The particles of salt pack more closely in the available space, thus reducing the volume. The particles of the salt pack themselves more closely into those available spaces between the water molecules, and therefore reducing the volume, as we have seen here. So the volume slightly reduces because the salt particles inside there have fitted themselves into the spaces of water particles, the spaces that are between the water molecules, and therefore the volume reduces. This further suggests that the particles of salt are broken down into smaller and smaller and smaller particles that will be able to fit into the spaces between the water particles. So the salt particles were bigger, but again they have been broken down into very small particles that are able to fit into the spaces of the water particles. And therefore, our conclusion here is that the salt is made up of tiny particles that we are now seeing that have fitted themselves into the spaces of the water particles. The water particles are also made up of tiny particles, which make some spaces between them, where those spaces the salt particles can fit into. So our conclusion is that matter is made up of tiny particles, and that is what we wanted to prove. Matter is made up of tiny particles. Another demonstration that we want to look at is Brownian motion. Brownian motion. Brownian motion, this was actually discovered by a man called Brownian. But we are not going to talk about the person who discovered. We are talking about the motion. We are talking about the Brownian motion. So what exactly do we mean by Brownian motion? What do we mean by Brownian motion? Brownian motion is the constant random motion of visible particles which continually are being hit by small or tiny invisible particles which are also moving in a constant random motion. So Brownian motion here is the motion of particles that we can see that are moving in a constant random motion, and these particles that we can see are moving in that manner because they are being hit or bombarded by tiny invisible particles. So there are two particles. There are some particles that we can see. There are other particles that we cannot see that are invisible. But these particles that we can see, we are having them so that they can show us the motion of those particles which we cannot see. The procedure here is that we are going to pour some water in a beaker. Pour some water in a beaker, about 3/4 of water there, and then as we can see, so we are going to pour some water to a certain level, a level which is not very much full or filling the beaker, about 3/4. Then we sprinkle some pollen grains. We sprinkle pollen grains or chalk dust. We have pollen grains here, so we are going to sprinkle some pollen grains. So we will pour some water to a certain level. Pour some water to a certain level. Then we sprinkle chalk dust. We sprinkle chalk dust on the surface of the water, or pollen grains on the surface of the water. So we sprinkle that to look at these visible particles. So we are going to sprinkle some pollen grains there, and then we view these pollen grains. We view them through. Of course, we are going to cover that. We cover that, and then we view using a microscope. We view them using a microscope. I've not brought the microscope here so that we can view, but we need to view using the microscope because we cannot use the microscope with the screen. So we are going to view the pollen grains the way they are moving with the microscope and see how those pollen grains are going to behave. So in our next video, we are going to see how those particles of the pollen grains behave on the surface of the water. So thank you very much, and let us meet in our next video to see what is going to happen.